Okay, I want to go with you through quadratic systems. And a system is where you have more than one function at a time. So we're going to specifically be looking at when we have two functions. And remember, we're going to be looking for the solution to the system, and this is where your two functions intersect. Now, when we dealt with lines, when we were dealing with lines, it was pretty straightforward. You typically had one point of intersection, unless, of course, your lines were parallel or they were coincidental, which meant you basically had one line on top of the other. So in parallel, you would have 0 solutions, and in coincidental, you would have infinite solutions. So we had special cases. Whenever we start talking about quadratics, though, that means we're going to have a parabola. Remember, that's the shape of a quadratic. So the shape of a quadratic is going to be, let's see here. Get this pen. And so we have a parabola here, and then we'll have a different, excuse my art, and then we'll have a line. For right now, let's just talk about how it works with a line. So it could be that your line intersects your parabola in two places. So we'd have two solutions. But it could be that your line only bumps your parabola, or it's tangent at one spot. So that one point could be your one solution. Or it could be that your line doesn't ever intersect your quadratic. So you could have 0 solutions. So just know that that's a possibility. Let's look at some specific examples. Now, when we work these, we're going to take each function and we're going to set them equal to each other, and we're going to solve them like we did our normal quadratic equations. Remember, we talked about multiple ways of doing that. Factoring and square root property are the fast, easy ways, but they don't always work. So if you don't have those special situations where you can factor or you can take the square root, then you need something else, which would be either completing the square or the quadratic formula. We know that these two will always work, okay? So when all else fails, you can pull out that quadratic formula and you can solve it. All right, so we're going to take these two functions right here, and we're going to determine the points of intersection, or the solutions. So I have taken those and I have written them on a piece of paper. So we're going to set them equal to 0, or excuse me, set them equal to each other, because we're wanting to know when the first one is equal to the second, which basically is saying when do they land on the same point. So now here's something interesting. I have a negative x squared. Now here's a big hint. Whatever your biggest power is, let me lock this in here, you want your biggest power to be positive. So we want x squared to be positive. So since it's not, I am purposely going to take all of these terms and I am going to make them go to the other direction, okay? There's not another x squared over here, so when I move it over, I'm just going to get a positive x squared. But since I do have a linear term and I do have a constant, I need to come in here and I need to show my movement. So subtract 5x, subtract 5x. Subtract 6, subtract 6. So now I can show that this is going to be, let's see here, 1 minus 5 is a, oops, that is a negative 4x. And look at there, my 6's go out. So that's all I have is x squared minus 4x. Hopefully you notice that we can factor this. And because we can factor it, we just take out our common term. So that gives me x minus 4. So I can take each factor, set it equal to 0, and solve it. This one's already done. Once we get x by itself, we're solved. And so that one's going to end up being a positive 4. So I have two answers, when x is 0 and when x is 4. Now, if I wanted to find the actual ordered pair, if that was something that you needed, you would need to go back into one of your original functions, and you would need to substitute your x value in to figure out your y value. So if that is something that you need, maybe you're on Math Excel or something else, y equals, and then I could put 0 plus 6. Well, that's just y is 6. So this would be 0, 6. So at that ordered pair, I know my line crosses my quadratic. And I can use the exact same thing over here. I can do x plus 6, but instead of x, I'm going to do 4 plus 6. So this one gives me 10. So my ordered pair is 4, 10. So these 2 points are the exact locations for my intersections. Okay? Let's see what it looks like if we do another one. Okay? If we take this one, let me write this one down. Got y equals x squared plus 6x plus 9, and then I have y equals x plus 3. All right, let's go back to our paper. I'm going to set them equal to each other. And I want to use the same strategy that I used before. I want to make sure that my squared term, my largest power, is positive. So I'm going to find this term and I want to verify, is it positive? If it is, I want all the things over here to go that way. If it wasn't, like on the previous one, we would go the other way. It really makes no difference which side your 0 is on. So since these need to come over here because this is positive, I'm going to subtract x on both sides, and I'm also going to subtract 3. I'm just purposely lining it up with the term that it corresponds with. So these go out. I know I'm going to get a 0. That's going to give me x squared, and 6 minus 1 is 5. And then 9 minus 3 is 6. Okay, so far so good. Now let's think, because factoring is the fastest way. If we can factor it, that would be great. So let's just double check. That's a 1, so it would be easy. Are there 2 numbers that multiply to 6 and add to 5? Yes, there are. So yay, bingo, we can do this. Those 2 numbers happen to be 2 and 3. The signs are going to be the same, and they're both going to be positive. Then we're going to set both of them equal to 0. And then when you solve them out, basically they just move to the other side and change signs. So this is our 2 solutions. Okay? If you need to find the y value, I would use the linear one right here. It's just a lot easier. So I would do y equals, and then I would put the negative 2 where the x is and work it out. So y is 1. If you're doing this, make sure you go ahead and finish it up, make it look nice by writing the ordered pair. So here I have y equals, and that would be a negative 3 plus 3, which is 0. So I'm going to have negative 3 and 0. Okay? So those are my 2 ordered pairs that are my points of intersection. Now let's see here. Let's do like one more. I want to specifically look at one that has the both of them squared. So this is a quadratic meeting a quadratic. Okay, so let's see here what would be interesting. I tell you what, let's scoot over here and let's just get this one because I've got it set up to where it's supposed to be an interesting little problem. So let's just see what that means. All right. Oh, excuse me, that's linear. I'm going to back up and do this one, the second one. Let's do the second one. X squared minus 4x plus 5. Okay. If I do that one, then when I set these equal to each other, I've got x squared minus 4x plus 5 equals negative x squared plus 5. Okay. I do need to get everything on the same side. Now I want to find, this one's negative and this one's positive. So this is the side I want to go to. So I want to add x squared on both sides. So please don't think those cancel out. When you add x squared on both sides, you're really going to get 2x squared over here. Okay. There's not, this is still here, so just bring it down. Nothing went with it. Now, if you subtract your 5, yes, they actually do cancel out. So this is very similar to the first problem that we did. You can factor out a common factor. You can factor out the 2, and you can factor out the x. Now, that means you got to divide. 2 divided by 2 is just 1, and then he had 2 x's, you took 1. So there's only 1 left. 4 divided by 2 is 2, and you took his x's. So then you can set the first part equal to 0, and you can set the second part equal to 0. So that's just going to be 0. Anytime you get something like this out front, it's always just 0. And this is just going to be 2. Again, if you need to actually find the y value, I would take one of the functions that we had before. What we had before was, quite honestly, let's just go with, we'll do this one because I haven't shown you that it works like this. You don't want to mix these numbers. When I'm looking for this ordered pair with the 0, I want to put 0 in both spots. That's 0 squared minus 4 times 0 plus 5. Basically, everything goes out except the 5. So I've got 0 and 5. If I did the 2, then that means I would put 2 here, and I would put 2 here. Then you have to work it out. So 2 squared is 4, 4 times 2 is 8, plus 5. So that right there is negative 4 plus 5 is 1. So I've got an x value of 2, and I ended up with a y value of 1. Okay, so that just kind of gives you an idea of the basic kinds of quadratic systems. We can do an upgraded version, and I'll show you that here in just a minute in the next video.